Assalamu alaikum. My name is Moaaz Ahmad. In this video, we are going to talk about example 1 to 4 of chapter 3 of our microcontrollers book. So, example 3.1 is right here. Here we can see that in this example, we are required to write a program to clear R20, which is a register, and then add 3 to R20 10 times. So, we want to add 30 to R20's value and then send the number to port B using the zero flag and brne command. So solution is also given here. So first of all, we are going to load the value 10 to our R16 register. This value will be used for our counter. As we can see here that we are required to add 3 to our R20 10 times. So this value will be used for our loop, as we will decrement it by 1 after each initialization. In the next value, we are going to initialize the R20 register. So first of all, we want to clear the R20. So we load a value 0 to our R20, and then we will add another value that we want to add to our R20, which is 3 right here. So we will add this value to another register so that we can add that register in our R20 registers again and again using this counter. So here we have assigned a tag, or we can say a label again, so that we can jump here again and again after each initialization. This is like a certain point we want our code to come back to after a certain line. So in this label, first thing we want to do is we want to add R21, which contains the value 3 right here, to our R20's value, which is 0 in our current scenario. So after the addition, we want to decrement the value of R16 so that the computer can understand that the loop has been initialized one time. The remaining number of iterations are 9. So it will decrement the R16's value, and then it will go back to our again label right here, and it will keep on doing so as long as the counter is not equal to 0. And when it reaches 0 after 10 iterations, R16 will be 0. Then it will exit this label and it will move forward to our output line, which is right here. In this line, we want to send our R20's value to our port B so that it can be displayed using 7-second display or any other means. So let's see this program in our simulation. So I will open the simulator from here. We are using Proteus 8 Professional for our simulation. So here I have placed the Arduino Mega. I am using 80 Mega 328p for our simulation, and with it, for displaying our value, I am using 7-segment display. So here we have written our code. So if I run it, we can see that it is telling me a value of 1e. The value is in hexadecimal format, as we can see right here. E in hexadecimal stands for 14 and 1 is 1. So if we convert it to our binary or our decimal, it will give us a value of 30. So our program is working. So now let's move forward to our example 2. So I will go back to my PDF, and here you can also see the instructions as we discussed earlier, that how all of these lines are working together. So it is first loading the counter, and then it is clearing the R20's value, and then it stores the value of 3 in our R21 register, and then it adds the value of R21 to R20 and store the value in R20 register, and then it decrements the counter. And then comes the check. It checks for if the counter is 0. If it is not 0, then it initializes these steps again, as long as the answer to this question remains no. But when the answer to this question is yes, like when the counter is 0, it simply outputs the result on our port B. Now let's move forward to our example 2. So example 2 is right here. So example 2 is asked, what is the maximum number of times that the loop in example 3.1 can be repeated? So we know that R16 is an 8-bit register. So it can only hold a maximum of 256 values. But as 0 is included in these values, so we can only move between 0 to 255. 255 is the maximum decimal value that it can store. But talking of hexadecimals, in hexadecimal 255 is equal to double F, as we can see right here. That's why the loop can only be repeated a maximum of 255 times. We will discuss it further in our next example, as it is also hinted here. So example 3.3 asks us to write a program to load the port B register with the value 0x55, which is a hexadecimal value, and then complement port B 700 times. So here is the same problem, that it is asking us to complement the port B 700 times, which is way out of our league, as we can only store a maximum of 255 in our register. So how will we execute this loop? For this, we will create two different registers, as we will see it in our code. So moving forward to the code, here we can see that first of all, it is storing a location to our R16 register right here using the LDI command. Then it is outputting that register to our port B. So our port B now contains this value right here 0x55. After that, for our outer loop, as we know that 700 is a multiple of 70 and 10. So we will divide it in these two loops. So for our outer loop, we will use the R20 register and we will store a value of 10 inside of that register. And then here comes the label 1, which is loop 1. In this label, we are going to load a value of 70 in our R21 register, so that it will be incremented again and again after each initialization. But when this register's value hits 0, the R20's value will be decremented by 1. Then this loop will be initialized over and over again for 70 times more, and then another decrement happens in our R20 register, and the loop continues for our R21 register. And here comes the loop 2. In here, we are asking it to complement R16, which is our main task in our example, as we saw right here. So we are going to complement the R16, and then we are going to output that register to our port B. So now we have complemented it one time. The next thing we will do is we will decrement the R21's value by 1. So the value will be 69 now. And then we are going to repeat it again and again as long as the value is not equal to 0. So it will repeat it 70 times, and the resulting value of R21 will be 0. Then it will move forward to the next step, where we are decrementing the R20's value by 1. R20's value is now 9. And then we are again repeating it from this label right here, that will result in R21's value of 70. So it will again repeat this same process, but this time when R20 will be decremented. So it will repeat the same process over and over again as long as the R20's value is not equal to 0. Only then it can exit this loop and finish our program. So if I move to my simulator, we can see right here. So here we can see the source code. The source code is written here. So if I run it, we can see here that it is displaying us a value of 55, or we can say 55, which is a hexadecimal value. So our code is working. Now let's move forward to our example 3.4. So if I move back to my PDF, example 3.4 is right here. In this example, we are required to write a program to determine if RAM location, and the location is given to us 0x200, contains the value 0. This is more of a check function, or more of a check question, that we want to check if the value is 0 or not. And then if it is 0, we want to place 0x55 in that location. So here we can see that we are given two things. First of all, we are given a location that we want to check, and then if a certain condition is met, then we want to store another value in that location. First of all, we have created a variable mylog for storing our location, which is 0x200, and then we load that variable's value to our register, which is R30. TST is used for testing a certain register. It is like setting a flag that it will check the register for a specific condition. In our case, if it is 0, it will move forward to these two lines, in which it will store the value of 0x55 to our R30, and then it will store that register to our location. So we can see that this step, LDS and STS steps, are both opposite of each other. And in LDS, we are storing the mylog value to our R30 register, and in STS, we are storing the register's value to our variable. But if the value is not equal to 0, then we want to branch it to next label. So for our next label, I will go back to my simulation, and here we can see that in our next label, we want to output its value to port B, and then we want to jump next again. So if I run it, we can see that it is showing us a value of 55, which is the value we wanted to store in that location. Now, if I go back to my source code and I change this value to something else, let's say I want to change it to double D. Now, if I compile it again, I can see that it is displaying me a value of double D this time. So our example is working correctly. That's it from this video. I hope you learned something valuable. Till next time, Allah Hafiz.